Good morning to all. Myself, Shankar Bhanose, Assistant Professor, Soeri College of Engineering, Pandharpur. Today we are going to see what is the application of trigonometry in our daily life. Okay. Let us start today's session, that is application of trigonometry. Okay. From ninth standard we have started the study of trigonometry. In 9th, 10th, 11th and 12th standard we have seen trigonometry. We have discussed the results of trigonometry, sine theta. We have defined the trigonometric functions, sine, cosine, tangent, cosec, sec, cot functions. Okay. As we know, trigonometry, a concept which is related to the right angle triangle. Now, let us try to understand what are the applications of this trigonometry. At the time of theory part, you have learned so many results related to trigonometry, that is factorization formulae, defactorization formulae, identities and etc. Okay. Now in this today's session we will discuss what is some applications of trigonometry. Okay. At the time of introductory part, maybe some hints are given to you what is application of trigonometry. Let us discuss with some examples. Okay, let's start. Actually one of the important application of trigonometry is to calculate the height or distance of a tower or a depth of a river. These are some applications. For that we need some concepts. Let's try to understand these concepts. First one is line of the slide. Okay, line of the slide. What is the line of slide? It is, we observe that the generally children usually looks up to see an aeroplane when it passes overhead. This line of joining their eye to their plane while looking up is called line of slide. Are you getting my point? If you observe, generally if you look upward to see an aeroplane, the line joining to the aeroplane and the eyes of the children is called length of slide. Clearly if you observe the image, in the image you can see what is meant by line of slide. Okay. Next, angle of elevation. The angle which is the line of the slide makes with the horizontal line drawn away from their eyes is called the angle of elevation of an aeroplane from them. If you observe, here is the picture. In the picture you can easily understood what is the angle of elevation. If you are observing a aeroplane, then the slant, the line of slant and the horizontal plane, the angle of these, the blue shaded area is called the angle of elevation. Next, the angle of depression. If the pilot of an aeroplane looks downward at an object or the children on the ground, then the angle between his line of slant and the origin and the horizontal line drawn away from his eyes is called the angle of depression. In the picture you can see the blue shaded area, the blue shaded angle is called angle of depression. Slant height, the horizontal plane to the eyes of the pilot, that part is called the angle of depression. Okay, these are the three concepts: slant, line of a slant, next angle of elevation, and angle of depression. Okay, let's try to discuss some examples how to use these concepts in actual real life examples. The angle of elevation of top of a tower from the point of a ground which is 30 meters away from the foot of a tower is 30 degree. Find the height of the tower. What is given? The angle of elevation of a top of a tower from a point on the ground is given, which is 30 meters away from the foot of the tower is 30 degree. Okay, let's discuss. Consider a tower AB. I have given image here. We have considered image here. AB is a tower and the angle of elevation is a point C. From the point of C on the ground to the upper side, to the top of the tower, that is A. A is a top of a tower, B is the bottom of the tower, and C is the observer. From that, if you observe towards the tower, top of the tower, the angle of elevation is given 30 degree. That means the angle C, that means the angle BCA, the angle BCA is given 30 degree centimeter, and the distance of a tower from that point to the bottom is given 30 meters. Okay, I have mentioned there 30 meters. And second part, the height of the tower is AB now. Okay, we want the height of the tower, that means AB is equal to question mark. Okay, let's consider in the right angle triangle ABC. If you define the tan 30, that is a tan C. Tan 30 is equal to, what is the value of? It is opposite side upon adjacent side, that is AB upon BC. AB upon BC. We know that tan 30 is equal to 1 upon root 3, and AB upon BC, the distance of the observer to the bottom of the tower is 30 meters. Therefore AB is equal to 30 upon root 3. If you simplify, you will get the answer as 10 root 3 meters. Therefore the height of the tower is 10 root 3 meters. This is the problem of application of the trigonometry to find the height of the tower by using the concepts angle of elevation. Okay, next one more problem we are going to see. Let us consider one more problem. A kite is flying at the height of 60 meters above the ground. The string is attached to the kite is temporarily tied to a point on the ground. Inclination of a string with the ground is 60 degree. Find the length of a string, assuming that there is no slack in the string. Slack means the line should be straight. Okay, the string is straight in this way. Okay, same problem, let K be the kite and the string is tied to the point P on the ground, and the given inclination angle means angle of elevation. They have given the angle of elevation is 60 degree we have considered, and what is the given? The height of the kite which is flying above the ground is 60 meter, the first statement. Okay, and what they want find the length of the string. They want the length of the string means KP. They want KP. What is the distance of the string? What is the length of the string? Okay, let K be the kite and string is tied to that point P on the ground. Okay, so that if you complete the diagram, it looks like this one. KLP, right angle KLP. They have given the distance 60 meters. Okay, and the angle of elevation, that is inclination, is 60 degree. Therefore KL upon KP is equal to sine 60. How we have defined? Sine 60 is equal to what is the property? Opposite side, that is KL upon KP. KL upon KP. that is 60 upon kp. Sin 60 is root 3 by 2, therefore kp is equal to 120 upon root 3. Again, if you simplify this one, we will get 40 root 3 meters. Hence the length of the string is 40 root 3 meters. Okay, this is one of the important application of the trigonometry, calculating the height, width of a river, the distance of a lighthouse from the boat. These are the some applications of the trigonometry. Okay, thank you.